All right. So we're going to talk about NetOptics, which is a software-defined networking controller. It's a product of Veracity Industrial Networks that, of course, Dynics is tied very closely with. Who in here, and I know the Interstates guys are familiar with it, and I know a couple others might be to a minor degree. Who in here understands what SDN is or knows what SDN is, or at least the concept of SDN? Okay. Some of you have it running in your buildings and facilities right now that are out here. So the idea behind software-defined networking is, it's been around for a while. It started out in the cloud space, pretty heavy, predominant in the cloud space. In fact, I'd say it's probably 100% coverage, software-defined networking. It's rolling through the enterprise space right now, meaning more and more enterprise organizations are saying, hey, that's a huge time saver. That's a huge effort saver. There's a money saver in there, so we can reconfigure things without having to go physically move cables and change ports. And so it gives you a lot of that ability. It also gives you the ability to see what's on your network at any given time. So you're not waiting for some other software tool to tell you what's out there after doing some sort of active or passive scanning. It's more or less telling you in nearly real time, this is what's out there. This is what it's talking to. This is how it's talking to it, protocol-wise. And then you have the ability to allow or disallow that. So think of it in terms of a firewall on every port of every switch in every panel. That's the control level you have. Think of it as a network tap on every port of every switch on your network. From a visibility perspective, you can see everything, every packet, every bit, every byte, every device, you name it, you can see it, okay? So a couple of the guys in the room here, they weren't around in the old, well, Sergio was around in the old days at American Axle when we first launched Ethernet IP in 06. And I'm here to tell you that in 06, having Ethernet IP as your only field bus cold turkey was a bit of a bleeding edge move on our part, right? Because in 06, people are like, Ethernet? What's a subnet mask? Do they ever change? No, they don't. So we'll just make them always 255.255.255.0. They never need to be anything else. What's an ARP cache? Well, you need more than 8 entries in one of those, you're nuts. Oh, okay, right? So it was, to say the least, early adopters. I will also go on to say that if we had this solution when we started developing and designing those networks, it would be a different ballgame today. Because this takes all the complexity, all the crap that we used to have to deal with, all of the one electrician unplugs from port 3 on the switch and plugs it into port 7. Well, guess what? Port 7 is trunked on a different VLAN than port 3 was and doesn't have access to the same stuff. So now you don't know why it's not working and you can't connect everything because the switch looks like it's properly configured. So remoting into the switch doesn't help you. So now you're scampering around to look at the switch to see the cable tag. Oh, hope the cable's tagged. Get me a print, see which cable's what, and hopefully it's plugged into the right place and finally move it around. Right? Joy of joys. Or your electrician that plugs a cable into one switch and then decides to plug the same cable into another switch on the same network. And they're not using something like, I don't know, spanning tree or something. What does a loop do to an Ethernet network? Bad things. Really bad things, right? So I've had electricians that plug them into one switch on one port. They'll plug them into the same switch. It's the other end of the same cable. But takes the whole network down. Everything is offline, okay? SDN networks, you can't create a loop, right? You're not able to create a loop. Won't allow a loop, all right? So
I told you rings weren't worth it.
That's the only way to do them, man, rings. Because with SDN, you get full redundancy and reliability with that extra piece of cable. No ellipsophobia required. One little piece of cable, Gary, you get redundancy and reliability. It's the most beautifulest thing. Actually, with SDN, you can make a mesh, right? Who in the world has ever thought, well, let's see, I'll make a ring around the outside, and then I'm going to make this guy an uplink here, and this guy way over here on the other corner is actually a camera station, so I'm going to run a cable from him to there, because the SDN network will pick the shortest passable route or shortest possible fastest route for that traffic. So it'll just pick that short route right across the network. but it doesn't affect the network and doesn't stop the network from working. I've just effectively taken all those hops out of my video or my pictures, right? That's pretty cool. Anybody ever done that with path costing on spanning tree? What a pain in the arse, right? Path costing is the way with spanning tree network that you can force the network to go certain ways.
And how many people do that wrong?
And how many people do it wrong is amazing.
Years later, right?
Yeah. The whole concept of what's a root bridge? How did you do path costing if you don't know that, right? So this takes all that complexity away. But the cool thing is it keeps all that security in place. So the IT guys love it because they understand what SDN is and how it works, and they know what it's capable of. The OT guys love it because we design NetOptics to think like we do on the plant floor. I want that PLC to talk to that robot over Ethernet IP. That's it, okay? So I'm gonna buzz through a little bit of this PowerPoint here real quick. Maybe.
You have the slide with what's the catch?
What's that?
What's the catch?
So far, I haven't found a catch. What is software-defined networking? I'm going to buzz through some of this mumbo-jumbo. There's a really good live demo out on Mac and Mac's website. If you go out to their website and look at their, what do they call those sessions?
Virtual lunch and learns.
Virtual lunch and learns. They have a full demo of going through the NetOptics controller and talking about and setting up a whole bunch of connections between PLCs and different things, and I say I did it, so that's why it's a great video. But it really talks about some of the stuff that I'm not going to have time to go into today, and shows you the communications, and I can make it talk Ethernet IP between a PLC and my laptop, but I don't let it ping, so I can't. ICMP doesn't go through, right? So it's kind of cool. All right, what are some of the OT problems we solve with it, right? Waiting for customer OT to configure switches. Never had that problem before, right? OEMers never said, and I know it's none of the OEMs in here, but the OEM has never said, well, we're way behind on this because your switch isn't configured. When in fact, they don't even have tooling made. But it's still, he's laughing because he wore one. Right? That's right. We can't do anything because that switch isn't configured. Darn it. We've lost 2 weeks. You're going to have to pay us for that time while we work fast to build that tooling that's still not done. Right? So there are those that might do such a thing. This takes that off the table because I just put the switch in learn mode, and anything that wants to talk is allowed to talk. So if they unplug their PC from this switch and run their lap down to a top to op10 switch and plug in there, and they try to reach a PLC back in op40 across the network, it'll let it. It'll write a flow to allow that to happen, right? So it'll basically configure the network on the fly automatically. So it makes it super easy. You don't have to run around and configure switches ahead of time. They plug them in, power them up, pretty close to done at that point. What other big one? Loops are fun. The switches in an SDN network are a commodity. I know the switching vendors love to hear that stuff. Rick over there just cringed. Because if they support the open flow SDN standard, don't care whose it is, it'll just work, right? Now, the caveat there might be our friends from Cisco because they never do anything quite like everyone else, even if it's the standard that everyone else follows. They have their flavor of the standard. And we're working through that right now on a couple of Cisco switches. But by and large, all the other switches we've tested or played with work just fine, including the Dynics switches, which, by the way, are some pretty awesome switches. But that's the cool thing. If you can get an SDN switch in the US that meets the OpenFlow standard and it's physically, like what you like, it's rugged, use it. If you go to Brazil and you can't get that same switch, but you can get, Bob's switch, and it works great, and it works great on SDN, use it. Would you ever put Stratix and rail switches, RS-30s, on the same network on purpose? Probably not. Because even though they're all Ethernet, it's different firmware, different configurations, possibly interoperability problems, right? It's gotten a lot better over the years, but they're still out there, right? Firmware incompatibilities. There's lots of reasons you wouldn't do that on purpose. In the world of SDN, it does not matter. Put a switch on there because the switches are dumb boxes of rocks until the controller tells them how to think. right? So it becomes a commodity item. It's whatever works best for you. Which is nice because then there's never an out-of-date backup on the switch, right? You don't have to back up the switches. The switches got their instructions from the controller. If I replace this switch, put a new switch in place, the controller's going to tell that one how it should work too, right? On the fly. So you don't have to worry about backups. What are some of the problems that we're solving? Visibility. I can show you every device on the network, where it's plugged into, when it moved, what it moved to, where it moved from, what protocol it talked, what device it talks to, or any list of devices it's talking to with any given protocol. I have absolute control over every device, every protocol. I could say, for example, allow protocol SIP on any, and that means the only thing that's going to go across that network is any device that wants to talk SIP. They'll be allowed to talk SIP. Or I could say allow protocol SIP on Op10's PLC to Op10's HMI. Then those are the only two devices on the entire network that can talk with only SIP. Can't ping, can't SSH, can't do any of this other junk that might be out there. No other protocols, right? That makes it pretty powerful. Makes it pretty easy to manage. You want to talk about zero trust? Deny by default. Nothing talks to anything unless you allow it. Period. End of discussion. Zero trust. You start degrading zero trust when you configure things. Human beings are the largest defeater of the concept of zero trust. We will never get to zero trust. That's a BS moniker, right? Because as soon as you allow this guy to that guy, you're saying, I trust that PLC, I trust that HMI isn't going to do anything wrong, so I'm going to let them talk with this protocol. But it's as close as you're going to get in the industry today, by a stretch, okay? Painful learning curve? Nah. Redundancy and reliability, it's inherent. If you have multiple paths, it will find the fastest path. If you lose that path, it will find the next fastest path. And you don't have to ask it to do it, it just does it, okay? You get a visual indication of your network with the topology. You can see the topology. I'm going to show it to you in a minute. So updated network drawing, don't matter. I can go unplug a bunch of stuff, plug a bunch of stuff back in. I still see exactly what my network is. No more calling down to the guys in Brazil where they're saying, it's just not working. Where's it plugged in? Well, it's plugged into port A on the front of this, this compact logic. Okay. And what's it, is it talking DLR or how do you got it configured? You got the supervisor turned off, right? Oh yeah. Right? And you spend 2 weeks trying to troubleshoot it to find out that it isn't in fact plugged into port A, it's plugged into port B. It doesn't in fact go to the right servo. The right servo is not even plugged into the network. And it's got the wrong IP address. In this SDN network, I'll know that in seconds. I will watch him move the cable from one port to another. I will watch him change the IP address on the UI. Okay? Very powerful. Fun fact, it is IEEE 802.3 compliant. That means this is standard Ethernet. The only thing different about this than any Ethernet network you have today is how we manage the network. Anything that runs on Ethernet today runs on this network. End of discussion. You want to run a higher level SIEM on the network? Great. You want to run, quick threat for Splunk on this network? Great. You want to run Clarity or any of that stuff or any internal apps that you guys may have? Great. Right? The cool thing is you've got absolute control over it. IT wants to come in and back stuff up? Well, you create a schedule. So from 2 o'clock on Monday night to 3 o'clock Monday morning or Tuesday morning, you allow SIP protocol to talk to that PLC, all your PLCs and all your HMIs. Asset Center comes in and does its job. 3 o'clock, flows are gone. It can no longer talk to your network. Something blows up in the process, you'll see it happen, right? It's cool stuff. What's that mean to normal people? Blah, blah, blah. So, go with the flow. SDN networks are built on a concept of flows and microsegmentation. Another great feature of SDN networks is there is no such thing as a VLAN. It's absolutely unnecessary. There is no such thing as spanning tree or protocols of that nature, PVST and all that. They're unnecessary. Okay? You can cable it any old way you want, and it will work. Okay? All of the junk that trips us up constantly out on the plant floors goes away. It microsegments. So if I'm trying to talk from this PLC to that HMI, that controller is going to see the request from the switch saying, I got this guy trying to talk to that guy. It's going to check its rules and say, are these two guys allowed to talk SIP? Now, there might be a rule that specifically points those two out, or there might be a generic rule that says any PLC that wants to talk to any HMI over SIP, go ahead. If it's okay, it writes a flow for that protocol between those two devices. So the network is drastically more segmented, or you will hear the term microsegmentation. Okay. I've never had anybody get my thing, so I'm going to point out the lightsaber for the L in flow. No one ever gets it. Right? May the flow be with you. If this is a connection and you somehow break that connection, the network is going to calculate the next fastest path. Now, future functionalities, and I'm not going to talk a lot about that today because I'm on a time budget here. We're going to create there's a capability in the OpenFlow protocol called an idle flow. So we're going to allow you to designate certain conversations as critical. And when that happens, we will calculate a primary flow, and haven't decided yet if we're going to allow you to manually pick a flow. Right now, the plan is to let it calculate the next fastest flow using as few common hops as possible to limit the ability to interrupt that second flow. And because the flow is already there, when comms go down on the primary flow, instead of milliseconds, it will be microseconds.
That's for convergence.
For convergence, yeah. For recalculating, because the flow is already there, we just enable it. We don't have to write
What's
it.
convergence like if you don't have that?
Milliseconds, right?
Compared to like a spanning tree or something like that.
Well, compared to spanning tree, you're way faster, right? It's going to depend a lot on the network, a lot on the amount of traffic, how much is pounding on the controller. There's a lot of values that go into that. If you're running on a Raspberry Pi, no promises that it'll even reconverge. You do need a little bit of horsepower, right? So the concept of allowed traffic, right? If the switch already knows that Ethernet IP was allowed between those two, because the first time it saw the traffic, the switch sent a question up to the controller and says, is this okay? Switch says yes, it'll never ask again. Okay? Gary, question.
I want to go back to the prior slide for just a second, if you want to.
Not that way, that way, that way. This way.
If I double this,
If you what?
if I double it, duplicate, there's another screen right over here.
Uh-huh.
Duplicate.
Uh-huh.
And there's 2 net optics controllers for 4 switches in the double.
Okay.
2 networks? And how do I go the cross flow between those 2 networks? I'm trying to understand the scalability of this.
So it depends on 2 things. Number one, how you configure the network. So it could be 2 controllers with 2 separate networks. Could be completely separate broadcast domains. Could be the same network with different broadcast domains. Could be the same network with the same broadcast domains. And you could put the second controller in redundancy, which means it sits there and just keeps syncing itself to the primary. Primary goes down, secondary takes over. The thing about the controller is the network will run, depending on if you use some of the super advanced features, it's got to have a controller because the switches don't have the smarts to make some of the decisions that have to be made. But if you just have a basic SDN network where you're doing basic stuff and normal networking type stuff, you can turn the controller off, network keeps running. The switches know what they need to do. You can cycle power to them, they'll come back up, everything is still fully functional, right? Controller is ancillary at that point.
And what is the way I interface to an existing network?
Plug it in.
No, I appreciate that. How does the controller does a flow between a traditional switch and one of the net flow switches that allow?
Yeah, you will see at the point where you connect. Let's say I put a switch up here, and a traditional switch, and I've got 3 devices on the traditional switch. When you plug that, and let's say you're using rapid spanning tree on that switch in VLAN 10, right? Or VLAN 10, 12, and 15, I don't care. When you plug that into our switch or the SDN switch, and this is a big difference between our controller and most, we're going to identify the VLANs on that port. We're going to identify that it's using spanning tree. And if you've enabled the capability for the controller to do so, it will talk back to it with spanning tree and on those VLANs, but only at the point of ingress and egress. We don't really care about it anywhere else in the network. You could actually put legacy, SDN, legacy, and talk from legacy to legacy across the SDN network. Now, I use the term metadata because that's the easiest way to explain this. When the data comes in this side of the SDN network, we look at the VLANs, we look at all the stuff, spanning trees. That data is carried across as metadata. So on egress to the network, we retag the traffic with the appropriate. And that's not exactly how it happens, but it's the easiest way to think of it. Okay. So yeah, you can do that. One of the biggest challenges that we run into right now is massive amounts of broadcast traffic and massive amounts of traffic because every SDN switch sends every packet that it doesn't recognize to the controller, and the controller has to deal with it. So we have this concept of automated drop flows. That means, say for example, you've got it on an Ethernet IP network running DLR, and you've got that beacon being thrown up at the controller all the time. Beacons are every 50 milliseconds, and basically the controller is going to say, switch says, here's a packet. The controller is going to say, no rules, throw it away. Here's a packet, no rules, throw it away. Here's a packet, no rules. And we do it every 50 milliseconds. That takes, the controller's got to spend some time on that. If there's no rule for it and we write an automated drop flow, it only happens once. Throw the packet at the controller says, I got no rule for that. Write a drop flow, never send it to me again. At that point, on ingress to the switch, it throws it away. Never gets on the wire, okay? So we've got a lot of cool features that help compensate for some of the creativity in the OT networks connected to traditional networks, for example, or even in this case, DLR. I don't know what time it is. I don't want to step on Ryan's time too much.
5 till almost.
Oh yeah, you might start a couple of minutes late. So allowed traffic, kind of talked about that, right? Allowed traffic that we've never seen before works like this. Controller tries to talk to the torque tool, switch sees a packet come in, switch says, I have no flow that knows how to handle this, sends that packet to the controller. Controller says, do I have any rule that allows this? If I do, instruct the switch that traffic is allowed between those two endpoints on that protocol, and it writes a flow down to the switch. From then on, the switch will never ask it again. What's cool is up on the controller, which is one of the reasons you always want to keep the controller running, is you'll see something like new device detected on the network, new device, new communications attempted, new protocol on the network. You'll see all of that because the switch reports all of that back to the controller. So you'll find out. So instead of running one of these tools where it goes out with spam ports every 30 minutes or every couple of hours and does a passive sniffing or maybe active sniffing and all that, and you give me 30, 40 minutes, you give a guy like Josh over there 45 minutes on your network before you tell somebody it's even there, you're toast. He just kicked a bunch of very senior guys' arses down at S4 in the Capture the Flag, which is basically a hacking tournament, right? He actually won a chunk of money for that, $750, right? Yeah, so he was in the top 5 almost the whole tournament, and all by him lonesome. Next year, we're going to send 2 or 3 guys in. We're going to tag team that bad boy. So when our name shows up above the Clarities and the Dragos of the world, people are going to go, ooh, who are them guys, right? So yeah, this will tell you in nearly real time what just happened on your network. Disallowed traffic, you'll notice that it's evil Siemens PLC. And I can't say evil Siemens PLC because I know we have Siemens users in the room. But Profinet, is it explicitly disallowed? Well, if the switch has never seen the traffic, what does it do? Nobody from Interstates can answer my question. Nobody from Veracity can answer my question. Back there. Outstanding. You, sir, have the choice between a happy ball and a blue football.
Happy ball.
Oh, send it over. All right. So when that happens and the controller doesn't see or sees an explicit block, what does it do? Anybody know? If the controller gets a packet from the switch, the controller has no rule to allow it, what's it going to do?
Send it back to the switch.
Send what back to the switch?
That doesn't have to be a rule.
We'll create a rule.
What kind of rule? Block rule?
It depends. Do you have system generated block rules?
Shut up, Dave. You can't talk. The short answer is it either tells the switch to throw it away because I don't have a rule and it evaluates it again, which is what you said. Or in the case of system block rules, it writes a rule back that says always block that traffic. Right? All right. That's worth a happy ball. Actually, Sergio, you get the football. And your answer was circling around right, so we're going that way too. Ooh, it lights up. I knew they lit up. Cool.
Yeah.
I bet you've never heard that before. All right. All right. Thing of the past. What's that mean to normal people? Blah, blah, blah. Let me buzz through all this nonsense. All right. So let me get rid of this PowerPoint. Let me open up this browser. So what I have on my laptop is I'm running a virtual network called MiniNet. So the controller is going to pick the fastest route between those two devices. And I haven't tested this in a while. And on this build, I'm not running like a release or even close to it. So I hesitate to try something like this, but I'm a glutton for punishment. I'm going to grab this guy and I'm going to grab this guy. It's going to show me that path. I can simulate the connection. I'm going to break that path, and the controller immediately rerouted traffic the next fastest path. Right? So this gives me the ability to actually simulate breaks in my network so I can understand how the traffic will be routed. If I had a mesh where I was crossing the middle here too, it would have taken the middle trap, right? It would probably gone from the corner up. Okay? Kind of cool. All right. So that's the topology display. You can pick anything on the topology display and get some details on it. I can see what the switch is, the IP address, whose hardware it is, the version. I can see that I'm managing it out of band versus in band. That's a whole nother conversation that I would love to have with you, but it's not a today thing. More important, I can see there are device types I know, and I can also see that on port 3, there's some device. Let me make my browser a little smaller. This resolution's killing me. I can also see that on port 4, there's a device with the IPs. These are switch peers, actually. These are my switches right to the right and the left of me, essentially, on what ports. If these weren't virtualized devices, I could pick them, and it would show me what devices were on each switch and on what port they were plugged into, right? And I can see the same thing. This guy is basically telling me what devices are here and what it can see from there. So the topology is cool. You can define zones. You can do real broad traffic control. So instead of me doing something like, I want this PLC to talk to this PLC, I can go traffic control. I can say do it over Ethernet IP, allow, go. Now all of a sudden SIP would start talking between those two devices only, for example. The other way I can do that is I can go to here and I can say I want everything that's a PLC or HMI, because I found that one first, to allow to be able to talk to everything. I can't even see my scroll bar on this screen, right? Over SIP, and I'm going to allow it. So now, when a switch, and we're changing this whole usability thing because both Jason and I hate it with a passion. You shouldn't have to do that whole stupid review, blah, blah, blah. It should be consistent with some of the other things that we do. But what I just did is I wrote a rule that says if I get a packet that comes from a PLC or an HMI, its destination is a PLC or an HMI, let it talk, write a flow. Okay? Stop and think about that. You just created a single rule that might answer or serve security on 500 devices. 100 PLCs and 400 HMIs can now talk securely, only over SIP, right? Pretty cool. Switch management lists all the switches in the system. You can do some cool stuff with them. We have this concept called cross-domain routing. So basically allows you to talk different across the switch. You could have a PLC, like in the world of GM, they have a PLC on the 10 dot network, a switch, and below it they have I/O on the 192.168 Class C network. You can talk through it to that, or you can talk 10 dot up to the rest of the enterprise, right? So it gives you the ability to have different addresses, and we do something called, it's called layer 3 groups in the world of OpenFlow, but we call it cross-domain routing because it's a little easier to talk about. There's a lot of features in here I can't demo for you today, but if you want to know more about them, get a hold of me. We can set up a demo and take a deep dive. Device management, you'll get a list of every device in your network. Its IP address, MAC address. We're building in some deep packet inspection because we happen to know how that works here at Dynics, where it'll go out and do a more deep dive on a device and give you its product code, firmware revision, serial number, all kinds of cool stuff. And then, hey, who knows if there wouldn't be a service that could say, oh, by the way, do you realize that those 12 devices you have old firmware and there's a PSA from Rockwell on that? You should address those. Kind of handy, wouldn't it? Not that anybody's doing that sort of thing, but just in case. Policies, those two things I did actually generated these rules, right? Allow proto-SIP on device to device, or allow proto-SIP on type HMI to type PLC. Once you get familiar with this syntax, you probably will never use the other ones. You'll just zip in here and bust out a rule. Okay? You can create policies, which are groups of rules, and you can turn them on and off. We've got this cool demo where you swipe your badge, it lets you talk to a PLC for a certain amount of time, and then it locks you back out. You swipe your badge, it lets you talk to it again. You swipe your badge, the controller writes the flows. When that swipes out or log times out, it tells the controller to delete the flows through the northbound API we have. Change sets, logs, and alerts. Lots of cool stuff, right? So here's some different things. New devices, deleted devices, me trying to log in and forgetting the stupid login. But there's lots and lots of information by category. Spanning tree setups. Let's see. Licensing, scheduling, so you can schedule stuff. You can say, I want to allow Microsoft updates, SUS updates every Tuesday, because it's Patch Tuesday, every Tuesday night from midnight to 3. If it's not midnight to 3, we accept no SUS updates, right? We allow Asset Center in from 3 to 5. If it's not 3 to 5, Asset Center doesn't get in no matter how bad it wants to, right? And it can be all automated like that. And then I think the last thing I'll show, and it's not going to do anything for us on this particular demo because it is just that. There's no real traffic bouncing around. I can put the network in learning mode, and anything that tries to talk to anything now gets a flow. The controller will automatically create the flows, right? Now, once I've learned my whole network, let's say I add another switch to it, and I want to add that switch without having to put the whole network back into learn mode, I can also go into learning mode on switches. So let me go back to operational. Let's go see if it created anything out of curiosity. Nope, didn't figure it would. But if I went to switch management and I picked a switch here, I could say enable learning, and now just that switch is in learning mode. So anything I plug into that switch, the controller is learning what's trying to talk through that switch, right? Then you can go in and peel out if there's something that you don't like. Chances are with a brand new network on a secure network, it's not going to be a big issue, but you might get a flow that you don't like, right? If you can, just whack the rule that drove it. Makes it pretty straightforward. You can also disable learning. There's a concept of in-band and out-of-band. All I'll say about that is out-of-band requires a separate physical network to manage the SDN network. In-band actually uses the data network to do messaging between all the switches and allows you to manage all the switches on the same network. So you don't need a separate network. It's all dependent upon your level of security. One of our customers, Pratt Whitney, they're a defense contractor, everything is out of band. They will not do management in band. They will have a separate physical management network. That is the most secure, right? In the automation space, we ain't probably gonna ever do that, right? Most automation people are not gonna run a second network. They're gonna wanna run it all in the same one they've already got cable for, all right? So that's NetOptics, lots of cool stuff. like I said, if you want to learn more, let's get together and talk, right? I'm available. Jason's available with Veracity. We can talk more and set up a demo or things of that nature. Come over to the office in Ann Arbor and see some stuff set up. We got a bunch of networks. Gary.
Target pricing?
Target pricing, there's, as far as getting into that today goes, there's 3 basic levels. There's advanced, enterprise, and what's the bottom one?
Essentials.
Essentials, right? So if you get a smaller company that just wants to get in and have a network, but they don't have a billion endpoints and they don't have to get all the fancy extra features that we have. We have a Net Insights tool, which does some other stuff, and they can go with essentials. And then you can upgrade to the other ones anytime you want to, right? You can add more capabilities and functionalities. So figure it out. Figure it's, I'm not a pricing guy, and we're not going to talk about it here anyway, because our partners in the integration and distributor space typically set that price. Figure it's 10,000, 25,000, and 50,000, right? And don't write it down because that's not real. I'm just trying to give you an example of the scale, orders of magnitude. Thank you.
Per switch.
Yeah, that's per switch. Yeah, 50K per switch. Yeah. All right. Any more questions about this right now? I will tell you, it's the coolest stuff that I think I've ever worked with in this space, other than my own stuff. Right? Any questions?
So the controller like runs on a Dynics PC?
It can run on a VM, on a server. It can run on a PC. I'm running it on my laptop. It doesn't require anything. You basically, when somebody buys it, they get an ISO from us. It's a hardened OS. It's Linux based, I'll tell you that, but it's hardened. You can't get to it, log into it, or you access it only through the UI. We manage patches and updates. There's a spot in the controller where you can apply patches and updates. There's a place you can download support bundles if you have problems or questions. You can send us the support bundle and we can look through it and see what's going on. Stuff like that.